Hello, this is Lab 5, Create Your Own Adventure for Physics 2211. Introduction to the purpose of this lab. This was designed to investigate a physics principle of your choosing, either through experimentation or computation via GlowScript Python. I decided to stick to an strictly experimental approach, and I will be analyzing collisions between two pool balls. In the real world, there are no perfect collisions. That's a little spoiler alert for the results. Moving on to the physics principles, the main ones being the conservation of momentum and conservation of energy, saying that momentum in a system is always transferred, not created or destroyed, along with energy being transferred. Another thing noted here is elastic collisions. In a game of pool, the collisions between the balls are near perfect inelastic. Meaning that the momentum is transferred really well, only a slight amount, which we'll talk in a second. The change in energy is conserved, the momentum in is the same as the momentum out, and here is the extrapolated equation for momentum in and momentum out in a system of a collision, along with a simplified version down here that relates to the system we're talking about, where the two pool balls have the same mass and one of the balls is initially at rest. System is the ball, surrounding is the table. This is a small diagram of before and after the collision. All the velocity vector is in the red ball. After the collision, there is a tiny amount of velocity left in the red ball, and most of it is transferred to the black ball. On to a video of motion. Over here we have the graph position of the red ball and the graph position of the black ball. The point of collision is very clear, which was very good data to find. Over here is a screenshot of the tracker. If we look at the actual video, there was a slight deviation in the x-axis, which we'll show again. As for the results, point of collision is obvious, as previously mentioned, right around just under half a second. Sum of position shows the optimal elastic collision position and slight energy loss. The sum of positions is this little gray dot that I added to see that the change, the slope in the position is almost perfectly linear. It's slightly off canter, but it's close to linear, meaning that all the momentum was transferred. Though this slide off canter can be further explained in the next slide, which takes the average velocity of the initial to the point of contact, and then the point of contact to the end. And as we can see, the point of collision is once again obvious, and slight energy loss is visible because of this total velocity line up here. Shows that it is clearly almost 5 inches per second under the initial velocity of the red ball. Sources could be x-axis movement as seen in the video, slightly imperfect collision, and extraneous forces. Maybe the felt was high frictive, maybe the pool table was not level, and other things like that. Some simple discussion questions created to talk about this topic. Were energy and momentum conserved? Yes, if the x-axis were evaluated. As previously mentioned, the x component of the tracker data was not taken into account and can be seen in the video as having a clear effect on the results. And as once again shown here, that little bit of velocity lost. Was this collision elastic or inelastic? It was a mix of both. All collisions are a mix of both. No collision is perfectly elastic or inelastic. There's always a slight amount of stick, always a slight amount of energy loss to extraneous things like thermal energy. Yes. Thank you.